In the previous video of this series, you've learned the general design and architectural principles that you can use in order to deploy machine learning models into production. In this video, I'm going to show you how to use a particular tool called BentoML to deploy your machine learning model into production. Let's get started. Here you have all the different steps that we'll be following in order to deploy a machine learning model with BentoML. First of all, we'll be training a sample model, a ConvNet, trained on the MNIST dataset. Then we're going to save the model to the BentoML local store and create a BentoML service through which we can serve the model. Then we're going to create a bento, building both the model and the service into a single unit of deployment called a bento. Then we're going to serve the model through a bento, the bento that we've just created. Then we're going to containerize the bento we've created and then run bento service via Docker. Here I am in PyCharm with a project which has all the necessary scripts in order to implement the different steps that we saw earlier. First of all, you have to install all the necessary requirements, which are BentoML, requests, and TensorFlow. We're going to be using Keras TensorFlow in order to create our example model. So you can use pip with this requirements.txt file, or just install all the different libraries as you prefer from command line. But if you want to install BentoML, you should do a pip install BentoML and install it in pre-mode so that you are going to get all the necessary pre-releases. Remember to do this if you're doing it from command line, otherwise just use this requirements.txt file. Another thing that I want to say is that if you want to get this project, you have the link to the GitHub project, to the repository in the description box below. So just go there and pull the project. Okay, so let's get started from the first step, which is, just want to remind you, the step of training a ConvNet model on MNIST. Okay, so for that we have a dedicated script called training.py. This is like a very straightforward script. I'm not going to delve too much into it, but here what we do is we train a ConvNet model built with Keras for classifying digits using the MNIST dataset. We're not really interested in having like very complex models. We're going to create like the easiest model possible, but all we care about is that we have a deep learning model, in this case built with Keras, and then deploy it. Right, so let's take a quick look at how this works. So here we have a main function that we can run here, and we have 3 or 4 steps here. So first of all, we prepare the MNIST training data. This means that we get back the train images, the train labels or the expected outputs, the test split with the images and the relative labels. Then we create the model via this function that we've implemented up here. We're going to take a very quick look at that later on. But yes, we just like build the ConvNet model, passing in the input shape that we expect and the number of output classes. So here we have like our nice Keras model. Then we do train the model via this function, passing in the model, all the train and test sets and the number of epochs. And finally, once we have the trained model, we want to save the model. So we pass in the model to this function, as well as the save path, which is just a folder called model, which is this one here. Okay, so now we know how like this main works. Let's take like a super quick look at build ConvNet model and train model. So build ConvNet model. So in this case, you can see that all we do is we just like create a Keras model. It's a sequential model. And so here we have like initial input layer. We pass this shape, so the input shape that we get here as an argument. And then we have a bunch of layers. So conv to d layers, max pooling to d. So these are like convolutional blocks, a couple of convolutional blocks. We flatten, we add dropout and final dense layer with softmax activation so that we can do the classification. We also compile the model. So we use Adam optimizer, categorical cross entropy as the loss, and we use accuracy as a metric. Okay, the final thing that I want to check here is train model. This is like super straightforward because here we just do a simple model.fit and we pass in the train images and outputs, the number of epochs, and we pass the validation data. Once that's done, we just return the trained model. Okay, so that's it for the training. So we can run it real quick so that we are gonna get a trained model. So here, if I remember correctly, we have just like a single epoch. Yes, because we want for this to be as quick as possible. Given it take a little bit longer, I'm just gonna fast forward to the end of this. Training is finished, so we can see our model saved here in the model folder. You can see the assets, variables, and these other files. Yeah, that's great. So now we have our model. What's the next step? Well, we need, as you can see here, to save the model to the BentoML local store. So what's the BentoML local store? Well, it's a local store that allows us to manage all our models within Bento in a very, very simple and straightforward manner using a CLI or a command line interface, or the BentoML command line interface. Okay, but how do we save the a Keras model, for example, to the BentoML local store? Well, we have a script for that. It's super straightforward. So here I just like built a single function that takes the model file, or I should say probably the model path, because it's like the whole folder that we get here. Okay, so we get like this model file, let's call it like this, it's fine. So we load the Keras model from this model file or model path, and then we save it to the BentoML local store. So how do we do that? Well, first of all, we load the model using Keras. So we do a keras.models.load model. We pass the model file, and then we run this instruction here. So BentoML.Keras, and this means, oh, by the way, BentoML is something that we've imported. So it's the BentoML package. Okay, so we have the BentoML, we do .Keras, which basically means we are within the Keras API. If we were to work with scikit-learn, here we would have done something like BentoML.Scikit, and if it was PyTorch, it would have been BentoML.PyTorch. But given we are working with Keras, we have to fetch the Keras API. So BentoML.Keras.save model, and we pass this, that's the name of the model. This is going to be a tag applied to the saved Bento model, right? And then we are going to pass the Keras model here. Okay, so this is all we need to store the model within the BentoML local store, but this instruction returns a Bento model, and out of that we can just extract the tag. And so here we are just printing that. But before I run this, I want to just show you guys the BentoML. So an instruction that we can use with the BentoML CLI. So BentoML models. So here you see that we have a lot of things that come with BentoML models. So you can use this command. So BentoML models delete, for example, you pass the tag and you delete a model in the local store. You can export it. You can list all the models. So let's try to do that right now. Let's see. Oh yes, we have a model. Probably I saved this model before starting recording this. So yeah, let me just like delete this one, for example. Okay, so I'm going to do a BentoML models delete, and then I'm going to pass this tag. Okay, and I'm going to say yes, and okay, so we just deleted the model. So now if we rerun BentoML models list, you can see that we don't have any models at all at this point. Okay, so now let's run this, and let's just give it a second, and there you go. Okay, so here we just like printed this statement. So BentoML Bento model tag is this one. So Keras model, which is the one that we've passed here, along with a unique identifier like this. Okay, so this is some information that we'll need later on. Okay, But what I want to do next is just like coming back here and doing a BentoML models list. And as you can see, we have our nice model registered in the local store, and the tag is Keras model with this unique identifier, which coincides with the one that we saw earlier. Okay, so now we have the model that has been registered in the local store. The next step, let's check it here, is to create a BentoML service. So what's a BentoML service? Well, the BentoML service, and by the way, I'm just like accessing it here, so I have a folder for that, so service.py. So the BentoML service is the equivalent of what you would have, for example, when you deploy or you create a service for your machine learning model with Flask or Fast API. Basically here, you are building all the necessary endpoints that you want to expose to the external world. This is like where you are actually making the inferences. Okay, so how does this work? Well, this is really, really straightforward. So first of all, we need to get the bento model tag, and I'm gonna have this as a as a constant and define it up here. So I just like pasted in the one that we've received, or we saw directly like from the saving process that we had. Okay, so the next step is to create a classifier runner. So a runner. So we want to create an instance of a runner. So how do we do that? Well, so we take BentoML, we enter within the Keras API, we get the model, and we can get the model via the bento model tag, which of course like is this one for our model, and we use this method called toRunner. And what this does is it creates an instance of a runner that wraps the Keras model. So why should we do that? Can't we just use the Keras model by itself? Yeah, we could potentially directly use that, but the runner has some additional features and behaviors that are very, very useful for BentoML because it optimizes inferences and computation. So it's always suggested to create a runner on top of your Keras, scikit, or PyTorch model like this. Okay, so now we have the classifier runner. Next, we want to create the actual service. And this is, to do this, we have to instantiate a BentoML service class. We can pass the name to this service, and we'll call it MNIST classifier, for example. And we have to pass all the runners. And of course, here we have only a single runner, that's classifier runner. But if we had multiple runners, we could just pass multiple runners here in this list. Okay, so now we have the MNIST service. The next step is super simple. We have to create all the different endpoints that we want. In this case, in this simple example, we only want a single endpoint called classify. In order to tell BentoML that this is an endpoint for a BentoML service, we have to use this decorator with this decorator. So we take the service and then we do a .api, and then we pass the input and output. So what is this NumPy and the array here in the input and the output? Well, these are like the IO descriptors. These are the IO types that we expect as an input and as an output. Now this NumPy and the array, as you can see, comes directly from BentoML.io. Here you have a bunch of different IO descriptors, but in our case, we expect ND arrays coming in. It's an image, right? And then as an output, we expect once again a NumPy and the array. So we should just let the service know the type of inputs and outputs that we expect. Good. So then we define the name of the endpoint, so classify, for example, and then we pass the input. So this input data that of course is an ND array, and it classify returns an ND array. And then making the inference is as simple as doing a return. We call the classifier runner, we call .predict.run, and we pass the input data. Now you may be wondering, but why do we need to use the BentoML service? Can't we just use Flask, for example, or can't we just use a fast API? Well, you could, but it would be way slower. And the reason is that the BentoML service is optimized for inferences, for machine learning computation. So this is way faster than what you would obtain with Flask and with Fast API, for example. The next step is to actually run the service. So we want to run the service, and then we want to hit up the service with a request. But in order to hit up the service with a request, we need a script for that. And I already wrote it here. So here we have a service request.py script. Okay, so how does this work? Well, so first of all, we have the service URL, and this is the URL that we're going to hit up. So of course, the service is going to run on localhost at in port 3000, and the endpoint is called classify. So this endpoint coincides with the name of your endpoint here within the definition of the BentoML service. Okay, so then let's take a look at the main. So first of all, we sample a random MNIST data point, and so we want to get the input data and the expected output, so the equivalent digit, so if it's a 0, 1, or whatever. Okay, so then we make the prediction, and to make the prediction we have this function that's called make request to bento service. So, and for running this, this function accepts two arguments, so service URL, of course, and the necessary input data. Now, once we have the prediction, we print the prediction, and we also print the expected output so that we see if our model worked properly. Okay, now we could go within these two functions, but I mean, these are like low level like implementations, so I really don't want to bother too much. So I'm gonna just like leave out like this sample random MNIST data point. You can check this like for yourself, but it's quite straightforward. But I want to just give you like an overview of how this make request to bento service works. Okay, so as I said, as arguments, we expect service URL and input array. So first of all, we want to serialize the input data. So we're going to use JSON.dumps. So we're going to dump the input array in JSON format. So we take the input array. This is a NumPy array, and we cast it to a list, and then we dump it in JSON format. So now we have the JSONified version or serialized version of input data, and it's time to make a request. In order to make a request, we use requests. So we use this library that we import and that hopefully we've installed as well. So we do a request.post, we pass the service URL, we pass the data, the serialized data, and we pass a headers variable where the content type is equal to application JSON. And then we return the response.text. We just are interested in the text. And that's what we get here. So that's this prediction that then we are gonna print here. Okay, so now we know all the different ingredients. So the next step is to run the service, and then we need to hit up the service running this script. In order to run the service, we have to go to another terminal. Okay, so I'm in the tutorials ML deployment folder where I'm basically here. Okay, so now I have to move to ML deployment and to service here. Okay, so now we are going to use the BentoML CLI once again. So we are going to do BentoML serve, and then we should pass the name of the file, service. Where is it? This one. So service, and then specify the name of the service or this object that we've created. So that would be MNIST service. And we're going to do a reload here. Let's run. Okay, so it's running, as you can see. So here we have the service that's running. So let's hit it up with a service request. And so we can run it from here. Let's run and see the results. And there you go. Yeah, we got back information. So this is like, yeah, this too. So the prediction and expected output are printed from here, right? And as you can see, we see that the service received a post request, and and that worked. Cool. So now let's take a look at this results. So here we have the prediction and the expected output. So the expected output is 1 here. So this is like a 1 digit. So it's the 1 digit. Okay. And let's take a look at the prediction. So if we take a look at this, so here, this is a 0.99. So yeah, the two things basically coincide. Remember that this is like the results like of the softmax activation that we have in the dense layer with all the 10 different neurons, right? That represent, each one represents like a different digit. So this is like the second one. So this is 1, the digit 1 that coincides with this one. Yeah, so the model worked. Cool. Okay, so now as you've seen, this is like a very simple way of deploying a BentoML service and to hit it up. But of course, this is not ideal. And that's because we want to build a model plus a service into a bento. So we want to deploy a model and a service into a bento. Remember, a bento is the unit of deployment, and that's because it has both the model and it has the service all in a single entity called a bento. So now we have to create that. So how do we do that? In order to build a bento, what we have to do is to create a bento file.yaml. We need to create a YAML file. So this YAML file needs certain things. So first of all, you want to refer to the service that you want to include within the bento. In this case, the service that we want is the service called MNIST service in the service.py script. Okay. Then we have certain labels that we can add. For example, here I added myself, Valeria, as the owner, and the stage of this service is dev. And then we should specify what we want to include. And here we want to include all the files that terminate for in py, so all the Python files. And we have other information to give within this bento file. So for example, regarding Python, all the necessary packages that we need in order to run the service. And these are two. So one is TensorFlow and the other one is NumPy. Okay, so now we have the bento file. In order to create this bento, we're going to go once again and use the BentoML CLI. Okay, so let's clear this. So you should be within the folder that has the service.py, and then obviously it has this bento file.yaml file. And at this point, all you need to do is a BentoML build. Okay, but before we do that, let me just do a BentoML list. So this lists all the bentos that already exist locally. Okay, and as you can see, I've already done this before recording this video. So I have another service called MNIST classifier with this unique identifier. Okay, so remember, this is different from BentoML models list. So these are the actual Keras models. These are the bentos. Okay, so now let's create a new bento. So we'll do BentoML build. Let's run this. So hopefully it's going to be fast enough. Let's see. Yeah, there you go. Okay, so successfully built bento, and here we get also the tag of of the bento that we have here. So now let's rerun the command BentoML list. And if you remember, we had only one bento earlier, and now we have two, because of course we have built a second bento, and they have the same initial tag, so MNIST classifier, but of course they have two different unique identifiers here, and our, like the one that we've just created, is this one. You can also see that the creation time is just, so we built this a few seconds back compared to this other one, which I created probably around, 12:20. Okay, good. So now we have the bentos or the bento. The next thing that we want to do is to serve the model through a bento. Okay, so we want to use directly the bento for serving the model, and then we are going to hit up once again the served model. Okay, how do we do that? We can use the BentoML CLI once again. I'm going to move to the terminal window, and then I can do a BentoML serve, and here, instead of passing the name of the service script and then the name of the service object, the variable that we have, rather than that, we're going to just call the name or the tag of the bento that we want to serve. So we're going to do a MNIST classifier. That's the one that we have here, and then we can pass. Yeah, we can just like pass all of it. So yeah, let me just like remove this and pass all of it. So we pass the actual tag with the unique identifier, or we could just do latest. So this is always going to serve the latest version of this bento, or the bento with this initial tag name, MNIST classifier. Okay, and then we're going to do a -- production. Okay, let's run this. Okay, so the BentoML service seems to be working fine. So now let me just close this. We will move once again to service request. Let me clear this one. And then I just want to hit up once again this guy, so the service, with a request for inference. So let's run this. Let's see the result. Yeah, and there you go. So we have a new result here. And as you can see, so we had a post request here with a status 200. It's difficult to see. Yeah, let me just like stretch it. Yeah, status 200. And it's the one that then like we received back here. We know how to serve a bento directly into production. Let's close this guy. Okay, I'm gonna clear. There's only one final thing that remains to be done, which is, well, actually two. So the next step will be to Dockerise the bento. So now we have this bento. Of course, we can deploy it as we've done right now, but in order to make it as DevOps friendly as possible, we can containerize it, which basically means we can Dockerize it. Okay, so how are we going to do that? Well, that's super simple, because once again, we're going to use the BentoML CLI that has an instruction for doing that. Okay, so let me close this one. First of all, let's take a look at the Docker images that I already have available in my machine. For that, I'm going to do a Docker images, and as you can see, I have two: an MNIST classifier image that I created 3 hours ago and a Minikube image. Next, we're going to be using BentoML CLI to containerize our bento, but in order to do that, we need the tag of the bento that we want to containerize. So I'm going to do once again a BentoML list, so that I have a list of all the different bentos here, and this is the one that we want to containerize. Okay, and then we do a BentoML containerize and pass the tag. Okay, let's go. Okay, yeah, there's probably containerise. Yeah, there's a typo over there. Yeah, I think it's fine now. Let's go. Yeah, it's working. So this is going to take quite a lot of time to being containerized. So I'm going to stop here and forward to the end of this process. We've successfully built Docker image with this tag, MNIST classifier G2K blah blah blah, right? So here I rerun the Docker images instruction, and now we have 3 Docker images. Fantastic. And the new one with this MNIST classifier, which was created just 35 seconds ago. Great. So now we have our bento Dockerized, containerized, and the next step that we want to apply is just to run the bento service via Docker. Just a quick reminder that if you want to follow along, of course, you have to have Docker installed. Okay, so now how do we run this Docker image? Well, we just have to run Docker, really. Okay, so we do a Docker run, and I'm doing this in the terminal window. Okay, so we do a Docker run P because we want to map ports. So we're going to map the port 3000 in the container to port 3000 in the host. And then here we should pass this tag, because we want to run this particular image. Let's run this. Okay, it seems to be working. So now the bento service is running within Docker, and now let's hit it up once again using our service request script. So we run this, and let's see the result. And there we go. We have our predictions and expected output, and you can check here that we've had a post request here with status 200. Fantastic. So now we know how to Dockerize our bento, and then how to run it and how to make requests to the Dockerized version of our bento. That's really, really great news. So let's shut down this service. Okay, so this is great because now that you have your Dockerized version of your bento, you can really, really deploy it wherever you want at scale. Indeed, there are 2 main ways of deploying these bentos or Dockerized bentos. So option number 1 is to deploy these Dockerized bentos with Kubernetes, so that you can like scale it up, scale it down like really, really quickly. And in order to do that, BentoML has a framework called Yatai that makes deployment of bentos onto Kubernetes clusters super, super easy. Then you have obviously another option, which is you have your bentos, you have your Dockerized bentos, and you want to deploy them directly to any cloud platform. So it could be GCP or AWS. And to facilitate this process, BentoML offers another framework called BentoCTL that makes this deployment option quite easy. And that was it for this mini-series on deployment of machine learning models into production. I hope you learned a lot about sort of higher level principles about the design and architecture of ML deployment, but also how to use BentoML in your deployment practice. If that's the case and you got value from this series, it would be great if you could give it a like and share it. That's all for today. I hope once again that you enjoyed this. I'll see you next time. As always, take care for now.